All right, I got this question and also this question from the same student. And earlier I was helping another student with both of these, and they're actually very similar. So I'm going to do them both. First, we'll start with calculating a margin of error. And if you open up your hypothesis testing guide form, there is a section for doing confidence intervals. And the margin of error is sometimes denoted ME and sometimes denoted EBM, and in my form it's always E. So the margin of error is something we calculate by multiplying the critical value times the standard error. And I've put copies of each of the different formulas that you might have to use there. And the one that we need right now is right here with the P hat and the Q hat in it, because this is an estimation for a population proportion. So to find the margin of error, we're going to use that formula there. So the things that we're going to need in order to complete this are the P hat, that's your point estimate. And it says here that the sample of size 165 had 15.8% successes. So that means that my P hat, the sample proportion of successes, is 0.158. And using that along with my sample size of 165, I can calculate my margin of error, but I'm going to have to do a couple steps first. So I'll put in my standard error formula, I'm going to do this part right here, the square root of P hat Q hat over N. So SQRT for square root, then P hat times 1 minus P hat would be my Q hat, and then divide by N, which here is 165. Then close the parentheses. So I had parentheses around the 1 minus P hat inside the square root, and then the square root has outer parentheses. So that's my standard error, and the critical value is Z alpha half, in other words, a Z-score for a two-tailed test. And we need to use our level of confidence here of 98%. So if I'm doing a level of confidence of 98%, let me show you the sketch so it makes some sense. The critical values are in each tail, right? And Z alpha half is the one on the right that I need for my calculation. And the area in each tail is half of my significance level alpha. So how do I get that? I need that area to help me find this critical value. So the confidence level was given as 98%. So that means that I want an area of 0.98 in between the two critical values, and that means that alpha is 1 minus 0.98. So that'll be 0.02. And we have to split it up into each tail. So this is 0.1 over here and 0.1, or rather 0.1 and 0.01 over here. So now I know an area that I can use to find a z-score. So I can find the evil twin over here and just change the sign. That's the easiest way, in my opinion. You can use norm.inv with an area of 0.01 to the left, mean of 0, standard deviation of 1. That's because they're z-scores. We always do a mean of 0 and a standard deviation of 1. So doing that here, norm.inv 0.01, comma 0, comma 1. All right, and I want that to be positive, so I'm going to put an absolute value wrapped around this. So my positive critical value is 2.326. To get my margin of error, I just multiply those two things, the critical value times the standard error, And if I was going to calculate the interval boundaries, I would add and subtract this margin of error. I would add and subtract it to my p-hat, my point estimate. So for this problem, we were only asked to give the margin of error, which is 0.066 when rounded to 3 decimal places. Let's see how that goes. We'll try that. And it wants it as a percentage. So I'm going to move my decimal place over here. In other words, multiply it by 100 and it'll be in percentage form. Okay, so that one's done. Now this one's very similar. It says out of 400 people sampled, 344 had kids. Based on this, construct a 90% confidence interval for the true population proportion of people with kids. Okay, so we're doing the exact same thing here. We're going to calculate a margin of error, and then we're going to add and subtract it from our sample proportion. So what is our sample proportion? It said out of 400 people sampled, 344 had kids. So my sample proportion is 344 kids, people who had kids out of 400 people sampled. So there's my point estimate, and I can use that p-hat to find q-hat, which is 1 minus p-hat, and use that to calculate my standard error, which I already have it all calculated here, but let's just do it again. So to get my standard, whoops, wrong side. Do that, this one right here. So I'm going to do the square root of p-hat times 1 minus p-hat and divide that by n, which is 400, and close the square root. And then also my critical value will change because I have a different confidence level. Here my confidence level is 0.9, and my area in each tail, well, my total area in both tails together would be 1 minus the confidence level, 0.1. So then the area in each tail would be half of that since it's two-tailed. Right, so my critical value will be found by doing absolute value norm.inv on my little half a tail, then comma 0, comma 1. So now 1.645 times the standard error, right? So the critical value times the standard error gives me my margin of error, which is already copied into here, right? And then I take my point estimate p-hat, and to estimate the population proportion p, I take my point estimate p-hat and subtract the margin of error for a lower boundary. And to get the upper boundary, I take that p-hat and add the margin of error. Okay, so that gives me my two boundaries for my confidence interval. And we're good to go on that one.